All right, so I've reset from the selection simulation that we had before. What I want to do is combine migration and selection. Why? I want to make the point that as we talk about these evolutionary forces, they don't act in vacuums. That I'm presenting them as separate evolutionary forces because they are, but they're fully capable of working together or against each other. So we talked about mutation introducing dominant deleterious alleles into a population and natural selection removing them, the two evolutionary forces working against each other. Now I want to do the same thing with migration and selection. And the example I want to use is the Lake Erie water snake. So the Lake Erie water snake lives on islands within Lake Erie, these Kelly's Islands, the Bass Island Complex, Pele Island. But it also lives in Ontario. And there are a few different morphs of the snake. You can see that some of these snakes have very strong banding patterns. And other snakes have more moderately banded, while this snake here really has no bands. Okay? Now, where these snakes exist with their different banding patterns, in Canada, specifically Ontario, the bedrock material is granite. Granite's very splotchy. Think grays, browns, whites, splotchy. And these banded forms do very well against this splotchy background because in this kind of situation, the banding pattern represents a type of crypsis. So you can imagine that selection would probably be very strong against snakes that don't have bands in Canada, and we would select for these banded snakes in Canada because they're harder for snakes to find. Sorry, my phone is going again. It's just like being back in the classroom. All right, on the other hand, on these islands in Lake Erie, the bedrock material is different. Instead of being granite, it's limestone. Limestone has a very different appearance. It tends to be white, no speckling, just a basic white to tan-colored background. And on this background, my expectation would be that the snakes with no bands would do better, whereas the snakes that have any kind of a banding pattern would stick out like a sore thumb against this limestone pattern. Okay? So in our minds, we could conceive of selection operating in these two populations, et cetera, to give us these different banding patterns. Well, the Lake Erie water snake is capable of migrating, and in fact it does. Migrations are predominantly from Ontario, where the snakes do very well, down toward these Pele Islands and the Bass Islands and Kelly Island. They're adapted to swimming in water, and that's what they do. So we get a migration of snakes from Ontario. Okay, so let's take a look at some data here. We have the unbanded, the moderately banded, and the strongly banded. And in Ontario, just like we would expect, a very large proportion of D, strongly banded, because of this granite background that the snakes exist against. Right? On the other hand, my expectation would be that on these islands, I'd have a lot of A. A represents the unbanded, doing well against the limestone pattern. And if you look here on Peninsular Island, right, so that's not labeled here, sorry, Peninsular Mainland, so that's here. Kelly's Island, that's here. A represents only 10% of the population. So the phenotype of the snake that we would expect to do best against predation is actually the lowest frequency or lowest percentage in the population. Well, why is that? Well, it's because selection is working against morphs B, C, and D, right, the unbanded and the intermediates, and selection is trying to remove these banded alleles from the population, but it's not having much success because every time it removes them, due to differences in fitness among these snakes, more of these migrants show up with these banded alleles, kind of swamping out the effects of selection. So this is kind of an unusual example here, but the idea is that in the case of these Lake Erie water snakes, migration is a much stronger force than selection and seems to be capable of kind of swamping it out. Okay? Now, one more aside, and then we'll get back to the simulation model again at the reconfigure. But worth saying again, a long time ago, I mentioned that we have to be careful of assuming that everything that we see in terms of traits and organisms represents an adaptation. If we went out to Kelly's Island, our conclusion would probably be, if we were an adaptationist, that the moderately banded snakes represents an adaptation to living on Kelly's Island. Well, it doesn't. In fact, it's a counter to what would be the highest fitness state, since no bands represents the highest fitness. But because of migration, we're getting a high proportion of individuals in the population that don't do well in that population. And as they're removed by birds, more of them keep coming through migration. So one of the reasons we can't assume complete adaptation in organisms is that migration can counteract natural selection very easily. Okay, so I'm going to shut off reconfigure. We'll do number 3, which I believe is genetic drift, and I'll see you on the other side.